In our last 4 sections of this unit, we are going to talk about a couple different types of quadrilaterals. And remember, a quadrilateral is a polygon with 4 sides. So in our section here, we're going to talk about parallelograms. And a parallelogram looks like this. It's got 2 sets of parallel sides. Our section 7.8 is a parallelogram with 4 congruent sides. So all 4 sides of that parallelogram are the same. A rectangle is a parallelogram with 4 right angles. A square is a rhombus with 4 right angles, or a parallelogram with 4 congruent sides and 4 right angles. And a trapezoid is a quadrilateral with only 1 pair of parallel sides. So we are going to go over all these in detail, but I just wanted a quick overview of what we will be talking about. So starting with section 5.7, we are going to talk about parallelograms first. So if we are given that our figure ABCD here is a parallelogram, then we know it has the following properties. The first is that the opposite sides are congruent. So that means that this segment AD and BC are congruent. And the segment CD and AB are congruent. We also know that the opposite angles are congruent. So if we look at A, B, C, D down here, we know that A and C are congruent. And D and B are congruent. The next thing we know is that our consecutive angles are supplementary. So since we know it's a parallelogram, remember these arrows mean parallel. If we have A, B, C, D, if these lines are parallel, these angles here, B and C, are consecutive interior angles. So that means angle C plus angle B is 180 degrees. And we also know that angle A and angle D is 180. Then if you look at the other 2 parallel sides, we also know that angle A plus angle B is 180, and angle D plus angle C is 180. And then our last fact about parallelograms is that the diagonals bisect each other. So if we look at this diagonal here, and this diagonal here, got A, B, C, and D. If our diagonals bisect each other, that means this side and this side are going to be congruent, and this side are going to be congruent in our parallelogram. So we can say that AM, we'll call this point here M, our midpoint, is congruent to MC. and DM is congruent to MB. Now, just because the diagonals bisect each other and those pieces are the same, this does not mean that the diagonals themselves are congruent. Just those pieces. This is important to remember. The diagonals of a parallelogram are not congruent. The other piece that you want to remember about diagonals is when they intersect, they form a pair of vertical angles. So if you look here, these two angles are vertical, those will be the same, and these two angles are vertical. They will also be the same. Okay, so then let's move on to our example at the bottom. And you will have to fill in this given information on your drawing of example 1. But our first thing that we are going to find is the measure of angle T. So remember, one of our properties of parallelogram is that we know that these angles, angle H and angle T, are going to add up to 180. So if they add up to 180 and we know one of them is 50, we can find the other one by subtracting 180 minus 50, which gives us 130. So T is 130. Then to find angle A, we know that our opposite angles are congruent. H and A are congruent, so that makes angle A 50. When you are doing these problems, make sure you have your notes out so you can look at the properties. You don't have to memorize these, they're right there on your paper, so use them to help you. And then our next side, AT, we know our sides are congruent, so if this is 10, this one's 10. HT, well, we know AM is 16, so HT will be 16. And then angle M, if we figured out this was 130, then M is also 130. Okay, one more example. Let's fill in our given information here. So you'll have to draw in your diagonals. Let's try that again. If we know that WS, so let's put our points, W, T, S, and R. Up here is our given information. If we know that WS is 20, we know our whole line here is 20. So we could write that over here, WS equals 20. But then right away, to label those pieces, I know that these two parts are the same. If the whole thing is 20, then I know this piece is 10 and this piece is 10. Then I know that angle RWT, this whole thing right here is 73 degrees. So this whole thing is 73 degrees. And then I know that RX, my side, so X is our midpoint here. RX is 8. Well, I know these pieces are the same, so if that is 8, then this is 8. Okay, so I can start filling in some of my missing information. The first thing it asks for is WRS. WRS is right here. Remember, R is in the middle, so that is my vertex of my angle. I know that this angle W up here is 73, and it has to be supplementary with angle R. So if those two add up to 180, I already know the top one is 73, so I take that away. That leaves me 107 degrees for angle R. Then it wants the measure of angle 1. So angle 1 is right here. Let's label those other ones. We have 1, 2, 3, and 4. And then angle 5 is down here. And there are two other pieces of given information that I forgot to label on here. So we know that this angle right here is 85, and this angle is 140. Okay, so if we know this angle right here is 85, and we just figured out that this whole angle R is 107, we can figure out what angle 1 is. So if we have 107 degrees minus 85, we are left with 22 degrees for angle 1. Now for angle 2, we have a straight line on that diagonal, and it is split into two angles. We have 140 here and angle 2. So to figure out angle 2, we can take 180 minus 140, and we are left with 40 degrees. Now angle 3 here, if you look at this triangle, oh, did not mean to do that. Let's try to erase it. Try that again. Okay, this triangle right here, we now know two of the three angles inside this triangle. We know angle 2 is 40. We know this one is 85, and we want to figure out what angle 3 is. So the three angles inside of any triangle add up to 180. If we subtract 40 and 85, we are left with 55 degrees for that angle 3. And we know that that whole angle W is 73 degrees. So if that whole angle is 73, and we found angle 3 was 55, that means there is 18 degrees left for angle 4. Okay, and then to find angle 5, if you look at our lines here, we have WT and RS. We know those are parallel because they are a parallelogram. Then we have this line here, this diagonal, cutting through, connecting our parallel lines together. That line is a transversal. So if you look at angle 5 here, that angle is an alternate interior angle to angle 3. That got erased a little bit. We'll rewrite angle 3. So that makes angle 3 and angle 5 equal to each other. If angle 3 is 55, that makes angle 5 also 55 degrees. Okay, then our next piece, it asks for xt. Well, we wrote that on here already. We knew that Rx was 8. It's going to be equal to xt, which is also 8. And then RT is that whole diagonal. If the two pieces are 8 and 8, the whole thing is 16. And then our last piece it asks for is XS. We knew WX and SS were both 10, so that is our answer.